Hi guys, today we want to continue with electrolysis. Remember that day we went through this, we talked about to predict, right? To predict the identity of the substance liberated during electrolysis, right? From the 3 points, from the state. Of course, here means molten or aqueous only. And of course, is for what? Ionic compounds only. Of course, covalent compounds with the ions. Okay, all right. Okay, molten aqueous and position. In your Form 5, the first thing you learn is what is being liberated depending on 3 laws of electrolysis. The first law is position of ions in the electrochemical series. So you learn by heart the electrochemical series, ECS. Right? But here, remember, you learn and then you use H plus this equation here and your OH minus. But now don't use it, okay? Don't use it unless you have to. You don't forget, then you right use water instead, because this one here to use the E standard. Remember, the H plus is 1 molar, and most of the solutions is not 1 molar. Aqueous means very low concentration. Also, OH minus here is 1 molar under E naught. Okay, so use water instead, and I'll show you. Sometimes, of course, you got a problem because the salt is an acidic salt. That one later I explain. Okay, and then concentration, of course, we've done already this one. We've done this too. Now, today I want to talk about the molten and the electrode potential required. Okay, and of course, hopefully, we can also finish the quantity of charge passed during electrolysis and the mass or volume of substances liberated during electrolysis. Okay, now these two figures here given here. We look into this. Okay, this is quite simple, right? And hopefully you can finish this too, and if you've got time, we go into the next one here, which is your Faraday law, okay? F equals to LE, or whatever I call it, okay? And of course, determine Avogadro's number, which is L here. So these two are linked together, okay? So now let's begin, right? Now, here I talk about molten, because last week I didn't talk about molten, or yesterday I didn't talk about molten. Okay, so let's say this is the first one that you did in Form 5, lead bromide. Lead bromide solid, remember, if it's solid here, it is what? A non-electrolyte. Non-electrolyte. Okay, the favorite question, of course, why? Because ions are there, but ions are not mobile. Okay, this is the answer. But of course, if it's liquid, which means molten, then the ions are what? Ions are mobile. They can move. Therefore, they can conduct electricity. That means they can actually run this whole process called electrolysis. Okay. So what is given out? So in this case here, very simple. You got only 2 ions, Pb2 plus and Br minus. So, well, this is a cell, negative pole. Okay, go to here, negative. It means all electrons are going here. Right? It means all electrons here. So Pb2 plus is the one, negative, right? So Pb2 plus is coming here. So this is a Pb2 plus ions is coming towards here. Right, and receiving 2 electrons, so it's going this way. Okay, so it's reduction. Okay, now this is the E naught value, the original E naught values, the one from the data booklet, minus 0.313. You can check it out. Okay, here you can check it out. Okay, lead PB. So I'm not bluffing you. All right, see now. Right, so you write in this way. You write the original way. Okay, original way. Okay, so in fact, it's reduction anyway. P2 plus 2E is in, right? 0 minus 0.13. So that's what I put down there. All right. Okay. Now, what is going to my positive pole, which is my anode here? Okay, positive pole is sucking out electrons. It means the negative field is coming here. Of course, right? So only one. So I copy this one from here. I'm going to show all this so you know what to do. Is it in exams? You got only your data booklet, so you must use the data booklet well. So bromine, where is this here? Yeah, this one here. Okay, I copied the whole thing here. The original E naught values, never mind. Br2, of course, it's going this way, you know, because we got our Br minus here, so it's going this way, right? So never mind. Keep that in mind. Plus 1.03 or 0.07. Okay, so here, so it's going this way. So actually, which means what the actual equation, okay, the equation for the reaction here. It's actually 2Br minus going to Br2 plus 2E. And of course, it's negative 1.07. Okay, right? But this is the original one. So this, of course, Pb2 plus is correct because it's uncle reduction, give you your Pb. So what is given out? Okay, what is the identity of the thing discharged? Is lead, which you see in form 5. You can see like at the bottom here is a silver, right? Down here is a silver globule. Okay, silver. Must say the color. Silver. Okay, ball. Okay, globule or ball. You don't know how to say globule, ball. Okay, silver ball or silver metal. Okay. And here, of course, is your bromine gas now, which is what? Reddish brown gas. Okay, reddish brown gas. If they should ask you, well, what is the lowest EMF this cell must have? What is the EMF of this cell for it to happen? Because to change this is the ions, right? To change this into elements, you need energy now. So you need energy. The energy here is, of course, the energy here required is what? Is electrical energy. And electrical energy here is measured in voltage, volt. That's why the EMF. Okay, so what's the lowest EMF you could require? From here, you calculate. See now. So remember, the E cell, for it to happen, would be, remember not, for cell is E cell equals to E what? Reduction minus E what? Oxidation. Yeah. But for E cell, for electrolysis of the cell required to undergo this electrolysis is you just reverse it. So what's oxidation? Of course, your bromide. So use the original one. Okay, here. And minus original one here. So a total of this energy, that means that the battery must be at least 1.20 or more than that. Less than that cannot. Okay, must be 1.2. Right, 1.2 watts. You can use your already battery at 1.5 watts. Okay, right. So now this is, I put it all under one so you can see that. Whichever one they ask you can see. Okay, you can talk about the identity of the thing given out, discharge, bromine gas, and lead metal. You can I can also write down the equation, the equation which is happening there. You can also now write down what the voltage of the cell requires the minimum voltage for it to happen. Okay, now here is a very simple, there are three such questions come out. I'll show you the 3, and I'll do 2, and that one you do yourself. Okay, so here's a simple thing about what is discharge from past question. Okay, electrolysis of zinc chloride can give different electrode products. See, so one substance here, right, under different conditions. Right, conditions will give you different electrode products. What is discharge? Remember, identity of the things discharged, the identities. Okay, remember, they always go back to the original. See, predict the identity of the substance liberated. They must fulfill what they ask you in the syllabus. The syllabus is very important. You need to always go back to the syllabus. Okay, otherwise you don't know what you're learning, man. You learn the nonsense. You fail, of course. Suggest the products form at each electrode. In following cases, one space given. Now, of course, they give this space. It means that they ask you to work it out. Of course, you can use for form 5 knowledge. Sometimes you can use confined knowledge because it's very simple. But I'm going to show you the form 6 way again, because sometimes it come out harder than this. You require equation. That's when the water is important. Okay. So now here is the liquid, which means molten. Now I'm going to show you again. It is concentrated. See, aqueous means got water. It's concentrated. It means high. That means the Cl minus here is definitely bigger than 1. Okay, well, bigger than 1, maybe 5, maybe 10. I don't know. Okay, very normally they say saturated. Sometimes they say saturated. It means very, very high concentrated. Okay, okay, and of course dilute means low. That means Cl minus here is less than 1.00. That means water is important now. Okay, that's this. Okay, now molten, of course, I told you already. Right now, for concentrated solution, I done all this. No, this one take me hours, man, to do that. Tell you cut and paste, cut and paste. Now, mind, I told you already. This is the main fact here. concentration of Cl minus is more than 0.1, okay? It's 5, okay? Right? Quite common, get 5 or 7, no? Okay. So of course, in your solution there, right? You got zinc 2 plus and Cl minus. The water, I don't want to put the H plus and OH minus, which you all do in formula. Don't want. So three things only. I put in blue color. 3 species to be involved with for discharge. Then 2 plus to consider Cl minus because of ions and because H2O. Now, even though there is no charge, but it can undergo oxidation reduction. Okay, again, I'm stressing to you so that you will not make a mistake later. You see how it comes out. They will tell you, they give you no chance. Okay, now, of course, anode, like here, if I draw the thing here, okay. Okay, so cell is here. All right, no space, never mind. Here's your zinc chloride. Okay, aqueous, but it's concentrated. This is your positive end, negative is your anode. And this is your cathode. Okay, that means in your anode here, electrons are being sucked up. That means the thing here will lose electrons, loss of electrons, the species here. So if it's positive, what is drawn to it? They can lose electrons, of course, Cl minus. Cl minus second to us, of course, go the other side, and must water. So the two of them, because water can also lose electrons. Like Cl minus will lose electrons. Water can also lose electrons, but all waters can get electrons. See? These two equations that you must know where to pick it up. No? Of course, zinc here, zinc will come to this side of zinc. Because this is positive. Okay? Come to negative side to take electrons in. So now I'm going to show you, of course, I'm going to show you how I got all these values, okay? So that you will know how to work it out if you need to. Okay? That's simple. Okay, chlorine here. Remember Cl minus, you go into this one here. Okay, Cl minus here. Okay, so you run the whole thing, don't care, according to the data board here, okay? But you know that this Cl minus is supposed to go this way, okay? So, see? So you call this one here, that means 2 Cl minus going this way. That means if you want to, because you want to use this to find the E cell, see? If they ask for E cell, never mind. Okay? Now for zinc, of course, it's quite down here. It's the last one because Z. Okay. Then zinc, of course, 2 plus here is going this way, isn't it? Reduction, but it's then positive, isn't it? Zinc chloride got second positive, right? And this is on here. So I got these two, right? So these two can see, I put down here, these two, this and this. Okay? So if you're not sure, you can write it down. Don't be too smart, okay? And say, I know, and then you fail. Now, water. How do you think water? Remember, in your anode, with Cl minus here, there's also water. Water also can give away electrons, can be an electron donor or a reducing agent. Okay, they donate electrons now. Okay, so they undergo oxidation. Okay, they donate electrons. Okay, like Cl minus donate electrons, H2 also can, and also can accept electrons. There are two different. You can see here. No, here. Okay, let me show you the two. Okay, now one of course is next to hydrogen here. Okay, see now, water accepts electrons. Okay, that means that it is going to accept, that means it's undergoing what? Water is undergoing what? Reduction. That means it's going to happen where? At the cathode, isn't it? Together with zinc. Okay, this one and zinc are partners. They both will accept electrons. Okay, so I'm going to quote this whole thing here. We're going to give hydrogen gas and H2OH here. See now, right? Accept electrons, give you H2 and so here. So the E naught is here. Original E naught. Okay. Now for water here to go this side, that means to give electrons like your Cl minus. Is there an E naught value? Yes. That means it's on this side. So much C on this side. Water. Where's water? Yeah, water. Water. Go inside now. Okay. So I quote the whole thing, right? So I know, well, O2 plus 4H plus 4 is 1, 2, 3. Okay, so I put down here. Okay, so I got all my things here now. So which is going to happen easier? So I'm going to apply a cell. Now, of course, zinc, let's say cathode first, since because it's going this way, right? Forward, is it? So for forward, which is Forward means that the E naught must be positive for it to be feasible. Negative means cannot. Okay, so Zn2 must go here. Now, which is, they are both negative, so both cannot. But which is more easier, which is less negative? Huh? Okay. Sorry. I forgot here. Okay, I come back to here first. Sorry about this. Now, here, I want to talk about this again now. Oh, I finished this already. I thought something wrong with me. Okay, just trying to check it out a bit. Now here, you can see Zn2 plus and water, these two. Now, because they are very near each other, they're very near each other. And there's a thing called over potential, which they don't teach. So Cambridge is very sneaky in the sense that, of course, you can see from here, I put hydrogen gas given out because it's correct one. But of course, because of over potential, it will raise, of course, you consider here, this is easier, right? Less negative, isn't it? So if you compare this one here, who is going to be discharged? Of course, zinc. Zn2 plus 2 electrons to give you Zn2 plus. Because why? Less negative, means easier, isn't it? Right? Okay. But because of over potential, because of hydrogen gas given out, blah, 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 this one will raise up to even higher. Okay. That's why this is given out. So you can see the marking scheme, they take it into consideration. See? Okay. Up down here. So don't worry if you come to such a crazy thing, because there are more theories about electrolysis. Okay, can be zinc or hydrogen, both is correct. So there's no mark given. Whatever is it, no mark. because they have not taught you in the syllabus about over potential. So don't worry about this. But go according to the E naught. Okay, they cannot get you wrong, right? It's good zinc, but I know because zinc got over potential. Okay, but I never mind now. Okay, so just let you know about this. All right, yeah. Now, of course, in these two cases, then this is important. These two cases. Okay. Now, to go backwards, Cl minus to go to Cl2 or H2 go to O2, which is easier for concentrated. Now, remember, if it's 1 molar, if this 1 molar, 1.00 molar, right? It is plus 1.36. We done that, isn't it? This very near each other. But as this go up to very high, increased concentration, it will go backwards more, isn't it? Right? It means become more negative. Okay? Right? Here, become more negative or less positive. Less positive. Okay? Go backwards here. So less positive will be less than this one. It will even go to less than maybe 1.05. Okay? Right now. So it becomes less positive. Okay? Here. Right? So in fact, if less positive, so more positive. Okay, go forward. Here is, I just think about it first. Okay, now here, remember, if it's 1 molar, right, is plus 136. Okay, but remember, if it's increased concentration, it will go backwards here. It means backwards becomes less positive, isn't it? Okay, so it's on here. Right? Okay, so less positive. Now when you go backwards here, because they are both are going to go backwards. So you go back, so this will be negative 1.05. This will be negative 1.23. So which is easy to go backwards? Of course, that's not. Right? That's why chlorine is given out when the concentration of Cl minus is very high. Okay, see now. All right, so Cl minus will, this is called a concentration effect. Again, now remember, if it's 1 molar here, I rub it off here. I'll just explain a bit more. Because I also can quite, the minus sign of things here is quite disturbing one. I know it. So I better think carefully first before I say anything. Okay, now remember, here is for 1.00 molar, which is this value here. Now this is going forward here. But this fellow here and this fellow here are going backwards. So now mind first. So remember, if the concentration is more than 1, say 5, right? That means it will shift backwards more. Right? That means this fellow here will be less positive, because it go backwards, right? Less positive, so plus now, Means this is the origin E naught plus 1.05. This remains the same. Yeah. Okay, this has decreased, become less positive. Yeah. So because it's going backwards, right? Because that means that to judge which is going to be discharged, right? To go backwards means this water will be minus 1.23. This will be minus 1.05. Now it means to go backwards, I must judge it from the backwards direction, the backwards EMF. So minus 1.05 and minus 1.3, which is smaller, which is easier. Of course, minus 1.05. That's why chlorine is being discharged. Okay. Right. So to go backwards is going backwards. That means you got to reverse the E naught. But to find the E cell, I must use the original E naughts. Okay. Oxidation, which means here, of course, this further is the one going to be selected. So the original one. Okay. Right. And here, of course, I said, who is up to you. Okay. In this case here, if you take this one 0. I said put here 0.8, 0.83. This one here. Okay. But normally this is not asked, but should they ask, you use one. Okay. Now for dilute, yeah. Right. For dilute. Okay. Again, now remember for dilute, we got the thing here. Right. So Zn2 plus will still go here. Water will still go here. Here, same thing. Same. See, these two are the same. Right? But the point, of course, now, because it's the same, this one, if you talk about here, right, because it's dilute, right? See here, the marking scheme, right? Halogens are halogen. It's always halogen one. Okay, so it's quite tricky. Sometimes that they don't, right? Very dilute. Okay, if it's very dilute, okay, that means you go right here, right? You be very dilute. Normally we use this one here. Okay, so water is normally used for very dilute. Okay, so here's hydrogen gas given out. Now here, of course, for very dilute to go backwards, which is easier? Which is easier? Of course, this is here. It's minus 1.23. It's easier, is it? So, so this is water. This oxygen given out, right? And hydrogen gas given out. Okay. So what left behind is, of course, the zinc hydroxide. Left behind, alkali substance. So you can see here, the answer: oxygen gas, hydrogen gas given out. Okay. So sometimes I know it's very tricky, to guess because of other theories also involved. So Cambridge, to protect themselves, they put ignore. Okay. So dilute always hydrogen gas and oxygen gas. Okay. Now next one here. Right. Now this one I leave it to you to try yourself because this one here is also very tricky because you must consider iron Fe2 plus is acidic. Okay, it's very acidic. Therefore, you can use a H plus, 2H plus 2 electron to give you H2 gas. That's why H2 gas is here. Okay, because it's very acidic. Okay, bromine is quite simple. Bromine and water you can consider Br. Of course, in this case here, your Br minus not. Okay, so it's Br2 plus 2 electron to give you, remember, Br minus here, and your water, which is this one here, plus electrons, okay, plus here, okay, here, remember here, okay, right? So you see the it's 1.23 now, okay, right? Okay, 1.23. This is 1.23 positive. Okay, and your Br minus, check, Br minus, so it can be quite tricky. Br minus, go back and think about it. Br minus here, Br minus, okay, see, plus 1.07, okay, see, okay, 1.07. So in this case here, this is plus 1.07. So to go back, sorry, what should be here? Let's put it properly, water, right? O2, 4H plus. O2, 4H plus here. O2 for H plus and plus 4 electrons, okay, it's 2 here, right? So remember going backwards here for anode is charged positive. So these two fellows here, go backwards, right? This will be minus. So this small minus, that means bromine is given out rather than oxygen. Okay, hydrogen here. Of course, silver, because silver is given out here because silver, now consider silver, right? Silver, the electrode there. I explain it better here. Okay. Yeah, and this one here. Okay. Now, silver, silver. Okay, silver in this example is easy to explain. Right? See, complete the table identifying the substance liberated for each electrolysis. Okay. Now, silver nitrate. Okay, concentrated sodium chloride and copper sulfate. Okay, now again, anode catalyst now. So complete table, identify blah blah blah. Do you understand? Right? Okay. So now what I did was I did the whole thing again. Okay, right? Now for anode. Okay, now, anode of course. Okay. Now if guys, if the anode, okay. Remember, there's no NO3, no. So very tricky the Cambridge, NO3, there's no NO3 reaction for oxidation. You can check here. Okay, NO3. See, oxidation means going this side, okay? NO3 only got for 1. You can see him here. NO3. See, NO3. All this, right? It's going to go this way only. That means undergoing reduction. There's none here, none on this side. You can check. I checked already. Okay, there's none on this side with NO3. There's none. All right. So you don't touch NO3 because NO3 is a very powerful oxidizing agent as well. Okay, right? It's not going to accept any, give out any electrons. So as I say, sometimes Cambridge, there are many things to consider, so don't worry about it, okay? Just sometimes use common sense, right? Now here, so you don't consider the NO3, right? Of course, water again, right? Water here and water here. Okay, so now these two, okay, of course, in this case here, water going backwards require a port negative 1.23. It means oxygen is given out. Okay, and the cathode, of course, the silver plus and water, which is easier, positive is easier. So silver is given out. So silver and oxygen is given out. See now, answer here, silver and oxygen. Okay, of course, for saturated NaCl we did before, right? Okay, so it's here, right? Remember, sodium chloride. This is these two, right? So sodium to be given out is a very negative. Right? Going forward. This one is negative, but it's easier. So like water undergoes reduction, hydrogen gas given out. Okay, and so what's left behind is what the sodium hydroxide. The solution become alkaline solution. Okay, now in this case here, right, saturated, of course, the Cl minus is going to be given just like just now. Okay, because this one become less positive here. Less positive to be positive 1.05. So going backwards is negative 1.05 compared to negative 1.23, isn't it? So this is given out. So chlorine gas given out and your hydrogen gas given out. See? HCl. So you can see here the answer is HCl. Okay. Right. Now the copper one you can see from here, right? Copper. Right. So same sulfate. You can see sulfate from here. Check it out. Sulfate SO4. Sulfate over here. Sulfate. Okay. Where's sulfate? Here. See sulfate. Okay. Undergoing oxidation of sulfate going here. So it's okay. 0. Don't take this one. Don't take this one here. See, there's another sulfate here. See now, another sulfate here. Don't take this one. Okay. This one is acting as an oxidizing agent, but here acting as a reducing agent now. It's supposed to be providing electrons. So you choose the correct sulfate. Nitrate cannot choose because there's only one. See now, okay? So for sulfate is here, right? Sulfate is here, and water is here. Because you don't use OH minus. Tak boleh. Okay, now, these two. Right? So you compare these two for copper sulfate, which is here to begin out, of course, is that going backwards is a smaller negative one. That's okay. This negative 2.01. So this is discharged. So oxygen is given out and left behind an acid solution. Of course, in these two cases here, right, reduction, water again here, minus here. Now, copper, I forgot to put, copper is, I think, very low. Copper is copper, copper. Okay, copper here. Okay, positive 0.34. Positive 0.34, be positive 0.34. Okay, of course, this is easy, isn't it? So copper is going to be deposited. So copper is liberated, so is oxygen. So what's left behind is your blue color. What's left behind, of course, is your hydrogen H plus and your what? So sulfate. Okay, so these two will give you a sulfuric acid as left behind. Okay, so now this is, as I say, can be tricky, whatever, but you have to do it. Okay, compare the E0. Normally, the difficult part, of course, is to use the water one. Okay, the water here, and the water here. Okay, now I need to go to one more thing, which is your for electrolysis. This one here, I got to give you here. Okay. Okay. All right. You can see here on the reactive anodes. Okay. I need to talk about it. Okay. Yeah. I was thinking, I forgot. I forgot this one. Okay. Never mind. We're getting to that now. All right. We'll probably stop this part first. Go to that one. Sorry about this. I messed up now. Never mind. We'll get there. I prepare all the other things except this one. Okay, this for electrolysis is part 6. Okay, it's down here because I forgot to finish. Now. All right, should be here. Okay, here. Okay, now this is the theory about electroplating, electrolysis of copper with impurities. One question came out like that. Let's show you this question. Okay, we try to finish this question as well. Okay, now, okay, the electrolytic purification of copper can be carried out in a process similar to the one shown below. Remember this one come up in, I told you there are three, what is it? There are three laws. Three laws of electrolysis. First, of course, is position of ions in electrochemical series. Number 2, concentration of it, like Cr minus and Br minus, they're always given out even whenever they're concentrated. 3, of course, what? They call this reactive what? Reactive anodes and cathodes. Okay, normally we don't do cathodes, but anode. So this we talk about copper and silver, right? Being Ag, sorry. In what? Electroplating. Electroplating and what? Purification of copper. Okay, so purification of copper here, there's this called purification of copper. See, impure copper. Okay, copper will dissolve. Okay, why? Okay, and the pure copper will be here. So remember in form 5, copper comes out here as CO2 plus. Copper 2 plus go to here as pure copper. Okay, now the whole thing here, this whole question here, all right? This whole question talks about it. Now, just let you read the question first, and then I go to the theory. So it's like a reverse thing, so you can see how it happens. Okay, so now this is a setup. Okay, electrolytic purification of copper. That means the copper here is impure, see, right? It means you got other things here. What are other things here? See here, the impure copper anode, right? Must be anode. Because why? In anode, what is this anode? Oxidation occurs. Okay, that means copper is going to be oxidized, come up as copper 2 plus electrons. Okay, right? Contains small quantities of metallic nickel. It contains nickel here, copper, zinc, silver, Ag, and inert oxides and carbon. Okay, other oxides and carbon. All this don't care, and carbon. Okay, and from initial reduction, the copper ore and the coke and so forth. The copper goes into solution at the anode. The silver remains at the metal and falls to the bottom as sludge. Zinc also dissolved. Now here, blah blah blah. Now I will explain to you what actually happens here in the theory form. Okay. So here I got here electrolysis of copper metal containing impurities of zinc, nickel, and silver. Okay. So I want to purify copper. So now I got here impure copper. Remember, the impure copper contains what? I told you zinc, silver, and nickel. Okay, and other things I don't care. Okay, I put the metals here because it's important, because here sometimes can contain gold as well. Gold and nickel. See, gold, also gold. Let's say I put gold here as well. Okay, gold. So inside this impure copper, there are 5 metals. But the main bulk is of course copper. The main bulk, main one. So these are small amount of impurities, small amount. Okay, right? And to get my pure copper, which is very expensive, this is a cathode here. You must start with a pure copper. Here is an impure copper as an anode. Remember now, because we say what in your form 5 reactive what anodes, you know. Okay, you learn your form 5. Okay, so now this is a cell. So once you on the here, what happens? Okay, electrons will flow from here. Ding dong, go here. And many electrons here. And there's the electrode force to suck out electrons here. Okay, to suck out electrons here. Okay, the force to pull electrons out from here. So which is easiest to pull? Now remember inside here, right? Inside here, the solution is copper sulfate solution. Right? So it will give you what? CO2 plus SO4 2 minus now. Okay, right? Of course, the water. Now I say don't consider this one. Don't consider your H2O becoming H plus square. Don't consider this unless you cannot do it. Okay, come out. Don't want. Cancel. Okay. So this one here. So inside here got three substances. All right. Yeah, I'm going to put red color. 3 substances, which is your copper 2 plus, SO2 plus, 2 minus, and of course the water. So what will get attracted to my anode? Of course, this one here, sulfate, here, sulfate, and water. Okay, they are attracted towards my positive pole. All right, right. Now, what about the negative pole? Here. Of course, the only thing that you can see is copper 2 plus. But don't forget water. Water also. Copper 2 plus, water at the beginning. Okay, so these 2 are going to the cathode, right? These 2 are going to the anode. Okay, now what other things can also happen? Now don't forget that inside here, because it's going to suck up electrons, it can suck up electrons from all these other metals also. Because all these metals here can also undergo oxidation, like here. Zinc can go to Zn2 plus 2 electrons. Silver can go to silver plus and plus 1 electron. Nickel can go to Ni2 plus 2 electrons. Gold can go to Au3 plus 2 electrons. Copper can go to copper 2 plus 2 electrons. That means all this must be considered. The 5 metals here must be considered. All this here must be considered together with these 2. Okay. Remember. they are going backwards. They are going backwards. Okay, they are going backwards. Now, if you consider these two further here, all right, going backwards is a negative 1.23. This is negative 2.01. So, which is from these two, who is easier to be discharged? Obviously, water is not, and of course, oxygen is given out. If this is, but then is there another thing easier? If it's going back this one here, this is minus 0.34. This will be plus, no? Right? This is your minus. This is your plus, no? This is a minus. That means which is easier to go out of all these 7 of them? 1, 2, well, 1, something. 1, 1, 2, 3, 4, 5, 6, 7. Of course, the positive one is it? Which is the most positive one? Zinc. Because going back is positive, right? Or you can say the most negative. I mean, normally it's the most negative here. So zinc will dissolve first. So when I start the cell, zinc will dissolve. Zinc will be oxidized first. Because to be zinc to be oxidized, I need positive 0.76. So, okay? But for water, I need negative 1.3. Means by itself, zinc will automatically go into the solution because it's very easy. It's positive, it's visible. So the first thing, of course, is like zinc here at the anode, zinc will dissolve. Because you must quote that because zinc, the anode is the most negative because you talk about the origin anode. It's the most negative, because this is all positive now. After zinc, all the zinc has dissolved. Which one will be dissolved next to go backwards? Of course, the nickel, which is positive 0.25. But of course, it's the next one, which is the most negative, is here. See now, the easiest to be judged, of course, nickel. So nickel, when all dissolve, nickel, then all have dissolved, nickel will next to dissolve. Okay? Right? So as nickel dissolve already, right, to give the electrons here, and then nickel, zinc and nickel dissolve already no more, okay, to give electrons here. So who will be the easiest to be discharged or to undergo oxidation? Of course, the copper, right? Because this is positive 0.34, this is positive 1.223. This is positive 0.8. So copper will be the main one, because of course, silver also can. But because it is more positive one, okay, then more positive than your copper. So copper will be dissolved first. And remember, copper is the main structure, the main thing of all is copper. So as copper dissolves more and more and more and more, these small bits of silver and small bits of gold, right, will drop to the bottom. Right, drop down here because it comes out here. Because the whole structure is basically copper, right? The main structure is copper. So these are called a sludge. And it contains gold and silver. This is how they get gold and silver from impure copper. Okay, this is called sludge. Anodic sludge, I call it. Anodic sludge. Okay, so this will drop at the bottom. Now, as it comes out here, that means now here in the solution there is a zinc, your zinc 2 plus, and your nickel 2 plus. Okay, so now inside the solution here there are 4 competitors to be discharged. Okay, according to the electrode potential. Now, to go forward, now we use the anode here, we can talk about the origin sign here. Okay, for H2 to be discharged negative, which means that it's not feasible, but it requires energy. Copper 2 plus is positive, zinc 2 plus is negative. Right now, okay, this is the original anode. See? Nickel is negative. So which is easier to be discharged? Because copper. Because it's positive. It's the most feasible. So copper is deposited. And zinc 2 plus, nickel 2 plus, all be left behind in the solution. Got it? Now, let's see how you answer the question here. Okay. All right, now here. Okay, now let's read the question again. The electrolytic purification of copper can be carried in a apparatus similar to the one shown below. Okay, blah, blah, blah. Now this is a cell, and this is impure copper. Of course, I said here contains, they tell you only nickel, zinc, and silver and oxides. Of course, they cannot, because they're solid, they cannot move. Carbon, of course, they'll go down here, the anodic sludge, anode sludge. Okay, it's pure copper here. The impure copper anode contains small quantities, smaller. That means the main structure, the main infrastructure is all copper. Okay, mainly copper, 90% copper. Okay, nickel, zinc. Remember the metal, silver, together with oxides of this and blah blah blah. Okay, initial. From initial, it means before you reduce it, okay, of copper ore and blah blah. The copper goes to the solution. They tell you copper goes. It means copper will dissolve inside here. I told you why? Because it's the what? Remember, the E naught is the most negative, isn't it? But reversely, it's the most positive, isn't it? Okay, right? It's the most. It's the least negative. Sorry. Okay, right. So here. See, can say here. I better repeat again. Okay, see. All right, now to go backwards, you can say copper is the most positive. Okay, no, most positive. Sorry, no, I mean for here, for here. All right, copper is the most positive. But here, what will dissolve first? Zinc. Because zinc is the most negative. Then comes nickel, which is the less negative, and then comes the positive ones. Okay. Here, for cathode, who will be deposited? The copper, because it's the most positive. Okay, because it's going forward. Right. So here, okay, and see, copper will go into the solution. Okay, will go into the solution at the anode because it is the most what? It's the most negative. Okay, copper. Right now. No. I mean zinc. Sorry. I got mixed up as well. But never mind. Let's say write a half equation stating the state of ratio of copper at the anode. Anode is it. So anode means that copper will dissolve, isn't it? So it's Cu. Look at the time. Copper at the anode. So anode is copper metal. Going to solid here, right? State symbols, my friend. Cu 2 plus equals plus 2e. Okay. Use the data from the data booklet to explain why the silver remains as a metal. Okay. Now I want to show you this. Okay. I think it should be here. Okay. See now this is the answer. Okay. Copper plus should bring over here now, plus 2 electrons. Okay. Right. On the right hand side. Okay. Now, the question here. Use the data from the data booklet. That means that you must use the original E naught values. Okay. Explain why silver remains as a metal. Why silver remains. Remember, the first thing that came out, I told you, was what? With zinc. Zinc come out first. Why? Because zinc come out first. Okay, here. Why zinc come first? Because zinc is the most negative, isn't it? See? Zinc is the most negative. It means going backwards is the most positive. Okay, right? Zinc come out first, then nickel. Why silver don't come out? Because it's more positive. E naught is more positive. See now, I look at the question here. It says here, use the data and data to explain why silver remains as a metal. Why silver and why copper dissolves? Why silver remains a metal? Why copper becomes an ion? Why copper becomes an ion? Why silver remains a metal won't come out? Okay, the marking scheme. Okay, see, you quote the silver, the original E naught, Ag plus is plus. So plus 0.8, which is more positive than copper. See now, copper, which is 0.3, positive. See, positive. See now, right? So because what, it is actually going backwards. So it's actually been negative 0.8. This is actually negative 0.34. So which is this to occur? Negative 0.34. So but when you answer, you must quote the original E naught values, right? Which silver is more, quote this one here, is more positive than 0.3 is copper. So it's less easily oxidized. That means this is more, copper is more easily oxidized. More easily oxidized. So it's very difficult try to explain, because it's reverse, see? Right? Because why? See, a silver Ag plus E Ag, this E naught represents what? The forward reaction, which is what? A positive 0.80. And CO2 plus 2E, forward reaction represents plus 0.34. But in your anode is undergoing what? Undergoing oxygen, because forward is what? It's reductions in it. But it's going backwards. But you got to coat it in the original form. So going backwards, of course, this becomes minus 0.80. That makes it minus 0.34, right? And which is easier to be discharged? Of course, the less negative one, right? But you must say it in the original positive one. That means why is silver not oxidized? Why is silver not dissolved? Why silver remains as a solid? Why copper? Okay, so you must say why silver. So you got silver, okay? Silver because it's positive, which is more positive. Because going backwards is more negative, is it? More positive than plus 0.34 copper, therefore more is oxidized. Yes or not? Very important, okay? It's how you answer the question according to the normal, the actual E naught value in your data booklet. All right? Now, let's go to the second question, okay? The third question here. I know it's hard to, you got to think carefully through, okay? I'm not, these A levels are not B levels. Use the data again to predict what happens to nickel. But nickel. Okay, nickel here, nickel here. Nickel here, okay? Nickel, right? Nickel here. Right, okay? Right. Minus now. Minus C now. Okay? So here. Now I told you, if all this is there, who is the first one to be oxidized? Zinc. Because it's the most negative, isn't it? Then comes nickel, which is the second most negative, isn't it? Right? Okay? That means it will dissolve. See, because it's negative. But going backwards is positive, isn't it? Now, how do you say it? See, so they go straight to the point. What happens to nickel? Nickel will dissolve, isn't it? Nickel will dissolve first, isn't it? See? Okay? See, you quote the E naught for nickel, which is minus. This is the original one. Because which means that means nickel 2 plus 2E to nickel here is negative 0.25. See, but this is for positive going forward, but going backwards means it's positive 0.25. So it's more easily to be oxidized than your copper. See, and I rarely oxidize and goes in the solution. Right? But they quote the E naught is negative 0.325, the original one, but actually it is positive 0.25. Understand? Okay, right now, next one. Think about it. You have to think clearly. It's English terms, that's why. Okay. Next one here. Write half equation for state symbols for the main cathode. Of course, cathode is a negative, so it's copper 2 plus equals plus 2E to give you what? One arrow, okay. Okay. Now, next one. Use the data in the table to explain why zinc is not deposited. Because zinc is the first one to undergo oxidation. Zinc will come up first, will dissolve first. See that? Right? Because it's the most negative of all. But backwards, the most positive, is it? Remember? So here, see, zinc is the first one to be dissolved. I'm going to rub it off first. I know the time is not for us. Here. Zinc, hold on now, guys. Zinc is the first one to dissolve. Right? In the answer, you say why? Because it's the most negative of all. That's all. But actually, it's the most positive when going backwards. See now? Okay? So how we explain it in exams? So now, but here it says, why is zinc not deposited? Let me see it. Why? Because it's the most negative. Because it's what? Here, right? Okay, because the E naught is very negative. Let's see how the answer here. Okay, how the answer is very important. Okay, good. The whole thing. Okay, now this one, this is the original one, Zn 2 plus, because it's reduction. E naught is negative, so zinc is not easily reduced. Because why? Because copper is, you can say, okay, as you can say, as compared to copper, and then give some here. Copper 2 plus 2E. Quote this one here. Here is negative 0.76. This one. This is positive 0.34. That means copper, because it's going forward, see, going forward. So copper is more easy to be released because it's positive 0.34. See now, okay? The best to write out equations and then quote them. Okay, zinc is negative, so cannot be deposited. Because negative means it's not feasible. But copper is feasible. Forward reaction, both are forward. Both are undergo reduction. Okay, right. Now, last question, then we'll call it a day, okay? All right. I didn't know it took so long. Suggest why the blue color fades as electrolysis because the copper is deposited there, right? Because copper is, because copper is being replaced. Copper is being replaced by zinc or nickel. Okay, so copper 2 plus equals copper 2 plus constant will decrease. Obviously, isn't it? Okay, the copper 2 plus will decrease, right? It's a basic one. Okay, I've finished this part here on the reactive anodes. Okay, please go back and think about this question. I think how to answer the question in terms of original E0 values. Okay, you have to learn this because see how they put of course going backwards is negative. That's why it's not so easy and so forth. This is more easier. Negative 0.34 for copper. Okay, guys, it's mind blowing. Okay, but the next time I'll see you, we do calculations. Okay, you think all this? I'm sorry, but it's just this way for Cambridge. Okay, bye bye and see you. Bye.